Hello, hello. Am I audible and is my screen visible? Please let me know. Am I audible?
Yes.
Is my screen visible?
Yes.
Okay. Okay. Good evening, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 8th live session, and in this live session I will discuss some practice problems on week 8 topics, which were mainly naive Bayes and Bayesian network, and also some boosting and bagging topics were also covered, like gradient boosting and random forest. So we will discuss some practice problems on these topics, and I will also try to answer your questions and doubts. So if you have any questions or doubts, you can ask me. We will start solving some practice problems, and after that, if you have any questions or doubts, you can ask me. So this is question 1. This is basically on Bayes theorem and probability. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that the number obtained is 4. Find the probability that the number obtained is actually 4. So Richa is saying option D. Okay. Vijay Satish is saying option D. Anyone else? Pentas Ravan says D already discussed. Yeah, it might happen that in some other live sessions it has been discussed, but those who have not attended those live sessions, they may try to solve this problem. Priya Kaur says D. Okay. So for this question, we need to think of 2 statements, and based on those 2 statements we have to form the question based on probability. So the first statement is that the person reports that the number obtained is 4. That is the first statement, and second statement is obtaining 4. So these are the 2 statements. So if the first statement is A and second statement is B, we have to find out the probability that probability of B given A, that the number obtained is 4 given that the person reports it is 4. So probability of B given A. So we can use Bayes theorem on this conditional probability. So this probability of A given B, that basically means probability of obtaining probability of reporting 4 if it is actually 4. So that is basically probability of speaking the truth. So that is 2 by 3, here it is given. And probability of B is obtaining 4, so that probability is 1 by 6. And then this one, sorry, it would be probability of A given B bar, probability of B bar. So this probability of A given B bar, this is probability of reporting it as 4 given that it is not 4. So basically he is telling a lie. So that probability is 1 by 3. 2 by 3 is the probability of speaking the truth. So probability of lying is 1 by 3. And probability of B complement, probability of B complement means probability of not getting 4, that is 5 by 6. And these values are already computed in the numerator. So you just have to plug these values in to compute the final probability. And the final probability will be 2 by 7 if you put all these values in. Option D. So all of you have written the correct answer in the chat. So this is how you have to compute this. Now question 2. Consider the following graphical model. Mark which of the following pair of random variables are independent given no evidence. So there are 4 options: A, B, C, D, E, D and C. Orijit Saha says A, Vijay Satish says A, Ritika Kestri says A, Harapriya Kaur says A, Pentas Ravani says A. So all of you are saying A. The correct answer is option A, that A and B, these two nodes are independent of each other given no evidence. So A and B, these are the two nodes, and we can say there is only one path from A to B. This is the path via C, ACB. This is the ACB. This is the only path from A to B. And if C or E is not given, in that case this path from A to B via C is not blocked. So this path is not this path is blocked. Sorry, C or E is not given, so this path is blocked here. A to B via C, this path is blocked, and this is the only path, and that is blocked. So A and B are independent, as no evidences are given here. But if you check the other options, so you will find that those are not independent of each other. For example, C and D. So C and D, there is only one path via B. So this B is not given. So B is not given here. B is not given, then this path is not blocked. C, B, D, this path via B is not blocked. So if path is not blocked, then those two nodes are connected to each other, so they are not independent. Similarly, you can check for the other options ED and CE, and you will see that all the other options are also not independent of each other. So only A and B are independent of each other. Yeah, so A, B are the only correct answers. Consider the following graphical model. This is the Bayes network given. Which of the following are false about this model? Multiple options may be correct. So option A is independent of B when C is known. D is independent of A when C is known. D is not independent of A when B is known. D is not independent of A when C is known. So you have to find out which of these statements are false about this model. So you have to find out which of these following statements are false about this model, not true. Harapriya Kaur is option C, which is D is not independent of A when B is known. Okay. Ritika Kesh, this is option C. Arijit Saha says option C. pentathlon is option A, B, C. Vijit Sahas is option D. Okay, so for this question, you have to check each of these options one by one, and you have to answer which of these are false about this model. So first one is A is independent of B when C is known. So A is this node, B is this node, and this node C is given. So we have to check whether each path from A to B is blocked or not because of this given node C. So this is the first path from A to B via C, and this is another path. So these are the two paths that we have to check. First we will check this smaller path from A to ACB, this path, whether this path is blocked because of C or not. So if C, this is the case of common child in case of d-separation rules. There are three d-separation rules. This is the common child because C is the common child of both A and B. So if C or any of its descendants are given in this case, then this path is not blocked. So this path is not blocked because of C. So A and B, this path is not blocked, so A and B are connected. So if A and B are connected, they cannot be independent of each other. So we have found one path which is not blocked, and if we find at least one path between the two nodes which is not blocked, then they cannot be independent of each other. There can be multiple paths, but if there is at least one path that is not blocked, then those two nodes are not independent of each other. So this statement is false. Second statement says D is independent of A when C is known. So D and A when C is known. So there are again multiple paths from A to D which we will have to investigate. So this is the first path, ACD, and then we have this path ACBD. This is another path from A to D, and we have ACED. This is another path. So the first path is ACD, and if C is given, this path is blocked because C is given. So this path is blocked. ACD, this path is blocked. So we have to check the other paths whether all the paths are blocked or not. This is the second path. So in this case, this path is also not blocked. Sorry, this path is given. So if C is given, this portion is not blocked, and then this CBD, this portion is also not blocked. Sorry, 1 minute. If C is given, in that case this is the common child problem, that A and B have this common child C. If C or any of its descendant are given, then this path is not blocked. So this portion is not blocked. And CBD, this portion, CBD, this portion is also not blocked because B is not given. So we have found a path from A to D. So this path ACBD, this path is not blocked by any of the nodes. So A and D cannot be independent. If there is at least one path that is not blocked, then it cannot be independent. So both option A and B are false. Then option C is D is not independent of A when B is known. So D is here and A is here and this B is known. So this is one simple path. And ACD, so this path is certainly not blocked by B. ACD path is not blocked, so A and D are connected. If these two are connected, they are not independent. So this is option is correct. This statement is correct. And then the final statement is D is not independent of A when C is known. So which is complement of option B. We have already shown that option B is false, then option D has to be true because option D is just complement of option B. So C and D, these are the two correct options, but we have to find out the false options. So correct answers are A and B. You have to find out the false options here, false statements. So A and B are the two correct options here.
One question here, sir. Whether these arrow marks are important, sir, to be noted?
Yes. So these are directed Bayesian networks. So for directed Bayesian networks, you have to take care of these direction of those edges. Yeah, because there are three rules. I hope that all of you have gone through those video lectures. So the three rules of D-separation. So you have to take note of those directions of those edges, otherwise you will not be able to find out whether nodes are independent or not.
So can you repeat again? I didn't understand how it is block and unblock with known and unknown.
Okay, so have you gone through those three rules of D-separation?
Yes, I saw in the video, but I didn't get.
Okay, so I will discuss those three rules briefly. So let's consider I, J, K. These are the three nodes. This is the connection, that I to J there is in a J to K. You have to take care of these directions of those edges. Otherwise, you won't be able to find out the correct answer. There is an edge from I to J and J to K. If this node J is given, so J blocks I and K, so they are independent. I and K, these two nodes are independent if J is given. This is the first rule.
If J is not given?
If J is not given, this path is not blocked. If J is given, this path is blocked.
Okay.
If path is blocked, then the two nodes are independent. If all the paths are blocked, you have to obviously find out all the paths from I to K. Here I am showing only one path. For example, A and D, there are the multiple paths, ACD, then ACBD, ACED. There are multiple paths from A to D. You have to check for all these paths. If you find at least one path which is not blocked, then obviously those two nodes are connected because of that one path only. Then those two nodes will not be independent. This is the first rule. Second rule is I, J to K. So there is an edge from J to I and there is an edge from J to K. So the directions of the edges are divergent, and J is given. Again the same thing, I and K would be independent if J is given. So you have to note the directions also, that there is an edge from J to I and J to K. So this is the second rule, and the third rule is I to J, sorry, and K to J. So both the edges are incoming to J. So J is basically the common child of I and K. So in this case, the independence rule is exactly opposite of the other two rules. If J is given or any of its descendants, let's say J dash, any of its descendant or J is given, then this path is not blocked. So they would be dependent. I and K would be dependent if J is given in this case. So it is exactly opposite to the other two rules. If J or any of its descendants, this here J dash is given, this path is not blocked in that case. Then I and K are dependent on each other. So these are the three rules. So this is the first rule, this is the this is the second rule, and this is the third rule. So these are the three rules that you have to apply based on the directions of the edges in the graph. For example, this A and B and C is given, so this is the path via C. So C is, so this this path falls under this third rule, because C is the common child of both A and B. C has incoming edge from A and also has an incoming edge from B. So if C or any of its descendant like E is given, then this path is not blocked. So that's why C is known here in this first option, and C is known, so A, C, B, this path is not blocked. So if this path is not blocked, obviously A and B cannot be independent. So this is what you have to do. You have to apply these three rules for each of the paths between the two nodes, and based on that you have to find out whether there exists at least one path between the two nodes or not.
So we have to check the all paths or the only one path?
Now all paths, like in this case for checking A and B given C, so this is the first path, this is the first path.
Yes.
There are other paths like A, C, D, B, this is another path, and there is another path A, C, E, D, B. So you have to check for every simple path, but if you find one path which is not blocked, then you don't have to check subsequent paths at all, because if you just need to find one path which is not blocked, then those two nodes are not independent. But if all the paths are blocked, then only both the nodes are independent of each other.
If one path is not blocked, then we can say it is independent.
One path is not blocked, then those two nodes are connected. So if the nodes are connected, they are not independent.
Yes, sir. Am I audible?
Yes.
Yes, I have a question that from suppose for this graph, suppose from B to D given C, then we have to check all the path, right?
You have
So for
to
that,
so A and B given C. So first
no,
you
B to B.
what?
Sir, my question is that B to D. Okay.
B
given
to
C.
B to D doesn't really matter, because there is already this direct edge from B to D. So those two are obviously connected, always connected, whether you give any evidence or not.
Okay, that's my question. That so it will be independent or not?
No, they are not independent. If the two nodes are connected, then they are not independent. D is dependent on B, isn't it? There is there is a directed edge from B to D, so D is certainly dependent on B.
Okay, so it's not independent, right?
No, they are not independent. Yes.
Okay, thank you.
Sir, J, if J is known, that means it is blocked, path is blocked.
J, for the first two rules, if J is blocked, then J is blocking the path if J is known. For the first two rules.
J is known means path is blocked, then the other two nodes are independent.
Yeah, but you have to check for other paths also. That is for only one path. You check that for that path is blocked. Now you check for other paths whether the other paths are also blocked or not. If all the paths are blocked, then they are independent.
How you check the that for first option, the A C E D B, that one, that route.
A C E D B.
Uh,
Yeah, so I didn't have to check this one because the first path itself was not blocked. So that's why I didn't check the second path. But for the this path, it would be here these are the two nodes for which you have to find out A and D, and C is known. So if C is known, C blocks this portion from A C E, isn't it?
yes, yes.
So C is blocking, so this path is already blocked.
Okay, okay. If any point it is blocked, that means it is
The whole path is blocked, yeah. And then you have to repeat the same process for all the paths. And when you find out one path which is not blocked, then you don't have to check the other subsequent paths.
So if one path is blocked, then if other two paths
No,
are
one
not-
path is, if you check that one path is blocked, then you have to check the other paths whether they are also blocked or not. If all the paths are blocked, then only they are independent.
Okay, okay.
And if you find
Or
one
if-
path which is not blocked, if out of n paths, even if one path exists, that means those two nodes are connected. If connected, that means they are dependent on each other.
dependent.
Hmm.
That means we have to
That
check
means for all
whether
the
one
path-
path is not blocked or not. If all the paths are blocked, that means they are independent. If one path is not blocked, that means they are independent.
Yes,
Dependent.
dependent. Yes.
Okay.
Question 4. So this is on knife base. Consider 20 budget phones, 30 mid-range phones, and 20 high-end phones. So these are the three classes: budget phones, mid-range phones, and high-end phones. And different features are given. Three features are given actually: single SIM, 5G compatibility, and NFC for each of these phones. And how many? So 15 is basically 15 budget phones have single SIM. 5 budget phones have 5G compatibility, and 0 phones have budget phones have NFC. So this is how you have to read this table. And now consider a phone with 2 SIM slots and NFC but no 5G compatibility. Compute the probabilities this phone being a budget phone, mid-range phone, and high-end phone using knife base. And the correct ordering of the phone type from the highest to lowest probability is, so you have to compute that. So for which class it has highest probability, which class it has lowest probability, you have to find out. Jayanti says option C. Harapriya Kaur says option C. So for this question you basically have to use Bayes theorem to compute the three probabilities. So for this phone which is given here, a phone with 2 SIM slots, NFC but no 5G compatibility, you have to compute the three probability values. This is the first feature, this is the second feature, this is the third feature. So if we name them as x1, x2, x3. Orijit sir, do you want to say something? You have unmuted your microphone. Okay. So x1, x2, x3, these are the three features. So probability of a class given this x1, x2, x3. So this is proportional to probability of x1 given C, probability of x2 given C into probability of x3 given C into probability of that class C. So these four probability values you have to compute and then multiply those probability values to compute the probability for that class. So there are three classes: budget, mid-range and high-end. So you have to compute three probability values here. So for example, for the first one, for the probability that it is a budget phone given 2 SIM slots, so I am represented as 2S, then NFC and no 5G compatibility, so complement of 5G I have written. So you have to compute probability of so 2 SIM slot basically means complement of single SIM. So single SIM is, if it is SS, so it would be complement of SS. So probability of complement of SS given B into probability of NFC given B into probability of complement of 5G given B into probability of B, which is probability of budget. So the first probability, that probability of complement of single SIM given B. So there are 20 total budget phones, out of them 50 are single SIM, so basically 5 are double SIM. So this probability would be 5 by 20. Similarly, this probability of NFC given budget. So there are 0 budget phones which have NFC, so it would be basically 0 by 20, so it is 0. So as one of these is already 0, so the whole probability would be 0, but I am still showing how to compute the other probabilities. So the third one is probability of complement of 5G given budget. So 5G, there are 5 mobile phones out of these 20 budget phones which have 5G compatibility. So there are 15 which does not have 5G compatibility. So 15 by 20 this probability, and the last one, the probability of that class. So there are 20 budget phones out of 20 plus 30 plus 20, so that is 70. So this would be 20 by 70. So you have to multiply these 4 probability values, and you have to do this for other categories also. This is for budget, then you have to do this for mid-range and also for high-end. So finally the answer would be C. So this is for the budget phone, this is for the mid-range, and this is for the high-end. So you have to compute these 3 probabilities, and then we can see that the mid-range has the highest probability, then high-end has the second highest probability, and budget has the lowest probability. This is how you have to compute. A drug test has 1% false positives. So the drug test is represented by the random variable capital T. So 1% false positive means 1% of those not taking drugs show positive in the test. 5% false negatives, that is 5% of those taking drugs test negative. Suppose that 2% of those tested are taking drugs. Determine the probability that somebody who tests positive is actually taking drugs. So taking drugs is represented by probability random variable d, and the drug test is represented as the random variable t. So the probability that you actually have to find out is probability of that somebody who tests positive is actually taking drugs. So probability of d given t you have to find out. I have not received any answer in the chat yet. So this question might be a little confusing, these terms, so let me explain this. So D is taking drugs and T is testing positive in the drug test. So basically the question asks you to find out probability of D given T, and what are the information given here. So first information given is 1% false positives. So false positive means 1% of those not taking drugs show positive in the test. So that is basically showing positive in the test. So probability of T given complement of D. So they are not taking drugs, still they are showing positive in the test. So that is 1%, which is 1 by 100. And then this 5% false negatives. So false negative means 5% of those taking drugs test negative. So probability of T complement given D. So they are taking drugs. Given that they are taking drugs, the probability of getting negative in the test. So that's why probability of complement of T given D. So this is this 5 by 100. And this 2% of those tested are taking drugs. So this is basically probability of taking drugs, probability of D. So these three probability values are given, and based on that you have to compute this probability of D given T. So Bayes theorem has to be applied here. Probability of T given D complement, probability of D complement. So this is the computation that you have to do. Probability of T. So first is probability of T given D, which is directly not given, but probability of complement of T given D is given. So basically it is 1 minus that, 1 minus 5%. So it is 95 by 100. Probability of D is given already 2%, so 2 by 100. This one is 2 by 100. And probability of T given D complement, which is given here 1%, which is 1 by 100. And probability of complement of D is 1 minus 2 by 100, that is 98 by 100. So all the individual probability values have been computed. Now you just have to multiply them and add them and find the probability. So this is how you have to compute this, and the final result would be 0.66, which is the option A. So is this question clear? Okay. So now question 6. A patient goes to a doctor with symptoms S1, S2, S3. The doctor suspects disease D1 and D2 and constructs a Bayesian network for the relation among the disease and symptoms as following. So these are the 2 diseases and these are 3 symptoms. And directed edges are also given from D1 to S1, D1 to S2, D2 to S2, D2 to S3. So this is the Bayesian network. What is the joint probability distribution in terms of the conditional probabilities? So joint probability distribution basically means probability of D1, D2, S1, S2, S3. This whole joint distribution. You have to represent it in terms of individual probability values in the conditional probability terms. Jayanti says option D. Okay. Manjula says option D. Harapriya Kaur says option C. Bhaven says option C. Okay. So to find out this joint distribution, basically you have to observe the direction of the edges. So first you have to check which nodes has no incoming edges. For example, D1 and D2, these 2 nodes are completely independent of any other node because there are no independent edges. So these 2 nodes are not dependent on any other node. So you can just write probability of D1 into probability of D2. Now for the remaining 3 nodes S1, S2, S3, you have to check the edges. So S1 has only one incoming edge from D1, so you will write probability of S1 given D1. Then for S2 you have 2 incoming edges, one from D1, another from D2, so you have to write probability of S2 given D1 and D2. And S3 has only one edge, direct edge from D2, so it will be probability of S3 given D2. So this is the overall probability, a joint probability distribution in terms of the conditional probabilities. So I think this would be option D. So you have to check all the nodes which are not dependent on any other nodes, so which are D1 and D2, and then for every other node which are dependent on some other nodes, for them you just have to check the direction of the edges. So S1 is dependent on D1, so probability of S1 given D1. S2 is dependent on D1 and D2, so probability of S2 given D1 D2. So this is how you have to write it down. Now question 7. In a Bayesian network, a node with only outgoing edges represents a variable conditionally independent of the other variables, a variable dependent on its siblings, a variable whose dependency is uncertain, none of the above. Harapriya course is option D. Jayantis is option A. Bhavan says option A. So if a variable doesn't, a node doesn't have any, only has outgoing edges, there are no incoming edges, so basically that node is not dependent on other nodes. Other nodes might be dependent on that node because there are outgoing edges from that node, but that node is not dependent on any other node, so it is conditionally independent of the other variables. So option A would be the correct answer. So dependency of a node on the other nodes depends on the incoming edges. If there are no incoming edge, that means that node is not dependent on the other nodes. In question 8, which among gradient boosting and AdaBoost is less susceptible to outliers considering their respective loss functions? Okay, AdaBoost, gradient boosting, and last option is on average both are equally susceptible. Harapriya course is option A. Jayantis is option A. So less susceptible to noise, gradient boosting is less susceptible to noise compared to AdaBoost, because gradient boosting uses squared loss function but AdaBoost uses exponential loss function. So it uses exponential weight for the nodes, for the data points which are misclassified, and so the loss function becomes exponential. So but in case of gradient boosting, squared loss function is used, so squared loss function is much less susceptible to outliers. It doesn't give much importance to outliers as compared to exponential loss functions. So that's why gradient boosting is less susceptible to outliers or noise points. Now question 9. How do you prevent overfitting in random forest models? Increasing the tree depth, increasing the number of variables sampled at each split, increasing the number of trees, all of the above. Harapriya course is option B. Bhav answers option C. So correct answer is option C. That if we increase the number of trees, so variance will decrease, and if variance is decreased, then it can prevent overfitting. So the problem in overfitting is that the variance is higher in case of overfitting, and if we can decrease the variance, then overfitting can be prevented. So option C is the correct answer. Increasing the number of trees in the random forest will prevent overfitting. Now question 10. Ensembling in random forest classifier helps in achieving reduction of bias error, reduction of variance error, reduction of data dimension, none of the above. Bhavan says option B. Harapriya also says option B. Pentas Ravani, do you want to say something? Ritika Kestri says option B. Yes, the correct answer is option B, that reduction of variance error is achieved by ensembling in random forest. So these were the practice problems that I wanted to discuss in this live session. Now if you have any other questions or doubts, you can ask me now. Okay, if there are no other questions or queries, then we can end this meeting now, end this live session now. Thank you everyone for joining.
Sir?
Yes.
So can you discuss the question number 6 of assignment 7?
So in that question there are some doubts. I have already seen that, and in the discussion forum also someone has posted some doubts regarding that. So yeah, as far as understand that if the threshold is that threshold and true positive rate, false positive rate question, right? That one.
Yes.
So if the threshold is decreased, both true positives and false positives should increase in numbers. So
both will increase.
Yes. So as per my understanding, both true positives and false positives should increase. And if we increase the theta, then both should decrease.
Tn and Fn will increase.
If we so if theta is increased, then those two will decrease.
Both are decreasing, and Tn and Fn will increase.
If theta is decreased, then Tn Fn will increase. If theta is increased, Tn Fn will decrease. So this is
sir, if theta increases, Tn and Fn will increase
So
and Tf Fp will decrease.
no, this is what is given in the answer, but as per my understanding, if theta is decreased, then both Tn and Fn should increase. So this is as per my understanding. Also the confusion is there, that's why in the discussion forum someone has posted regarding that, and also one of the live sessions TAs have also written that in the discussion forum that there is some doubts regarding that.
So it will be re-evaluated.
I don't know. The course team would check whether which one is the correct answer. But as far as understand that if theta is decreased, TNFN will TP and FP.
TP and Fp will increase.
TP and FP will increase, and if theta is increased, TP and FP will decrease. So this is as per my understanding.
Yes.
So I don't know what will be the final evaluation, but this is what I have understood.
So from this today class, the question number 4, the probability we discuss about the budget, mid-range and high-end. So can you show the slide again?
So this video lecture will be uploaded, recording of that will be uploaded, so you can watch from that.
Okay.
Here basically you have to compute the individual probability values. Probability of budget given three features for this mobile are given here in this line.
Yes.
So you have to split it in using Bayes theorem, this conditional probability you have to split, and then you have to compute for individual probability values. So this recording would be uploaded, you can watch from that.
Okay, sir. Thank you.
Sir, in the drag question, how you get the P of T given T?
Which question? Drug question. Okay. D this it's already written that 2% of those tested are taking drugs. So basically,
P of T given D.
P of T given D. This one is given P of T complement given D, which is this false negatives. So complement of T given D is given, so P of T given D would be 1 minus of that, 1 minus 5 by 100.
So what can we say for that? It is given for P probability of T given T complement. It is 1 by 100. So what would be the 1 minus 1 by 100? What probability it will be?
So it always the complement of the first variable. So probability of T given D bar is 1 by 100.
Yes.
So 1 minus 1 by 100, which is 99 by 100, will be probability of T complement given D complement. So the second variable will remain as it is.
Okay.
First variable will be complemented, and that would give you 1 minus that original probability.
Okay. First one will be the main.
Complemented, and second, on the all the other variables would remain the same.
Okay.
Okay, thank you everyone for joining.